Assalamualaikum and good morning. Okay, so let's start our class today. Okay, so this is back to basic. Okay, so objective to help our students in basic mathematics skill. Okay, that we can. Okay, so I'm sure that here we have students from applied calculus and ODE, ordinary differential equation. Okay, so we'll sit this subject, two subjects. Okay, the applied calculus or ordinary differential equation. Okay, let's me introduce. Okay, so let's recall. Okay, the important. Okay. Oh, sorry. Let me share my screen first. Okay, you all nampak ya my slide back to basic?
Yes.
Thank you so much.
Nampak.
Okay, so thank you. Okay, let's recall basic mathematics. Okay, a few formula. Okay, so we start with law and indices. Okay, so if A and B greater than 0 and M and N are any real number, then we have this. Okay, rules of indices. Okay, law of indices. So A power to 0 is 1. Okay, so don't always forget about this. Okay, A power to M plus N is actually equal to A power M multiply to A power N. Okay, so we use all these indices, law of indices, in order normally in order to simplify our final answer. Okay, specifically in ordinary differential equations. Okay, if we want to simplify our terms, okay, so we need to know all of this. Okay, A power to negative M is equal to 1 over A power M, and A power to M minus N is A power M over A power N. A power M in bracket is power to N is actually equal to A M times N. Okay, so don't confuse here. Okay, so don't always confuse with this. Okay, okay, it's not similar. Okay, it's not similar. Okay, so A M plus M is A power M multiplied to A N. But when we have a bracket like this, okay, this is actually A power M multiplied to N. Okay, so if you have tried to solve an Euler equation, okay, when we want to write back our solution in terms of x or in terms of t, then we need to know this. Okay, so AB okay, A power B power to N, A times B, okay, in bracket is power to N, is actually A power M times B power M. Okay, so we just want to recall all this. Okay, normally we use all these indices, law of indices, to simplify our final answer or to simplify, okay? In order to proceed to next process to solve ordinary differential equations, okay, we need to simplify our equation, okay? So you have to know this. Okay, so next is exponential and logarithmic function. Okay, so we know that y is exponent x. So x is ln y. Okay, when y is exponent x, okay, x is actually equal to ln y. Okay, so natural logarithms, we have this. Ln y is 0. Ln exponent 1 is 1. Ln exponent x is x. Okay, we can simplify this. So that exponent ln x is x. Okay, you must know all these logarithms, natural logarithms, so that we can simplify our terms. Okay, properties of the exponential function. So it's quite similar to indices, law of indices just now. So exponent x, exponent y is exponent x plus y. Is quite similar, okay, to what we have in previous, okay, law of indices. Okay, now properties of the logarithms. Ln to x times y is ln x plus ln y. Ln to x over y is ln x minus ln y. Ln to x power n is n ln x. Okay, so that's why sometimes we want to simplify. Okay, student make careless mistake here. Okay, so let me share. Okay, let's say you have this exponent to negative ln x. Sorry, let's put negative 2. Okay, student, sometimes there are a few students that make this careless mistake. Okay, they just write exponent negative 2 ln x is equal to negative 2x. Okay, this is totally wrong. Okay, exponent ln x equal to x. Exponent negative 2 ln x is not negative 2x. Okay, you must use this rule. Okay, let rewrite. Okay, exponent negative 2 ln x as exponent ln x power to negative 2. Then here we simplify because we have exponent and ln. Then this is actually equal to exponent power to negative 2. Okay, so this is not equal to negative 2x. This is actually equal to x power to negative 2 or 1 over x squared. Okay, trigonometric function. Okay, so we don't have to worry about this. Okay, because a few reciprocal identities we give to you in appendix in final exam or midterm test. Okay, we assume that you not memorize all this, but for sure you should memorize this. Very simple. Okay, for reciprocal identities, we have sine theta is 1 over cosecant theta. Cosine theta is 1 over secant theta. Okay, so you can read others. Okay, cosecant theta, for example, is 1 over sine theta. So why we need to know this? Okay, when we face with a trigonometric function, okay, in order to solve, to integrate, for example, to find a Laplace transform, okay, if we have a cosecant, secant, so we actually have to simplify those terms, okay, to sine or cosine terms, okay. Quotient identities, tangent theta is sine over cosine theta. Okay, this is simple. We not give you in this in appendix because we assume that all students at least can memorize this. Tangent theta equal to sine theta over cosine theta. Okay, but cotangent theta is cosine theta over sine theta. Okay, so Pythagorean identity, sine squared plus cosine squared is 1. 1 plus tangent squared is secant squared. 1 plus cotangent squared equal to cosecant squared. Okay. Okay, so others, sum and difference formulas, okay. Double angle formula, okay. When we use all this, when you want to simplify your trigonometric function, okay, in order to integrate or find a Laplace transform in ordinary differential equation, okay. For example, okay, we're going to use all, sometimes we use, okay, this, okay, to simplify our terms, okay, so that we can easily integrate or differentiate or easily find a Laplace transform, okay, to a trigonometric function. Okay, so product to some formulas. Okay, you don't have to worry. Okay, if you want to ask you these types of question, normally we give you. Okay, but bear in mind we actually have all this formula to simplify our trigonometric function. Okay, so we go to part 1, differentiation. Okay, the common notation that is used in derivative of y is fx. Okay, sorry, of y equal to fx. Okay, common notation that we use when we want to differentiate y equal to a function of x. Okay, so for first derivative, we have dy dx or f prime x, or sometimes we have y prime. Okay, so let's see. So we have a function y equal to 3x. Okay, so now we have a function y equal to a function of x, y equal to a function of x. So differentiate this equation. So we have dy dx. Sometimes we present our differential equation as dy dx equal to 3. Okay. Or we have f prime x equal to 3, where we differentiate fx, so we have f prime x. So that's why we have f prime x equal to 3. Or we can write y prime equal to 3. But in mechanical vibration, there's other way to write the differential equation. So for a first derivative, they use y with this one dot. Okay, so in mechanical vibration, for example, okay, so they use this style, okay, to present the derivative of second derivative, first derivative. They have these two dot. Okay, so second derivative d2y dx2, meaning that we differentiate our equation twice, or we can write f double prime or y double prime, okay, and so on, up to nth derivative. Okay, so let's move to basic differentiation. So first, constant and polynomial. So how we differentiate a constant or polynomial? Okay, we know that differentiate a constant is actually 0. Okay, where a is a constant, so differentiate a constant is always 0. So for example, we have when y equal to 20, differentiate this equation is 0. So dy dx is 0. Okay, when we have y equal to e, okay, e this is not a function of x, because we don't see any x, okay, for this example. Okay, so this is actually a constant because it's not a function of x. So differentiate this is also equal to 0. Okay, let's say we have y equal to sine 2. Okay, y equal to sine 2, dy dx is actually 0, but sometimes students confused. They know that differentiate y is cosine, for example. So they have dy dx is cosine 2. This is wrong. Okay, look at your equation carefully. If you don't have any x on your right hand side, that means this is not the function of x. Okay, so what is this? This is only a constant. Differentiate a constant, we have 0. Okay, so for number 2, differentiate a polynomial. Differentiate a polynomial, for example, we have x power n. So this is equal to n times x power to n minus 1. Okay, we multiply n to the front, and this n minus 1. Okay, for example, we have y equal to 3x squared. So 2 times 3, we have 6. 2 minus 1, we have 1. Then we have dy dx is 6x. Okay, how are we going to differentiate this? 1 over x squared. Remember, we can rewrite this. Okay, we can rewrite this as x power to negative 2. Okay, that's why you have to know all the basic mathematics. Okay, we can rewrite this as x power to negative 2. Then from here, we know that, okay, differentiate x power to negative 2. Okay, we multiply negative 2 in front, so we have negative 2. So we just copy x, and negative 2 minus 1. So that's why we have negative 2 x power to negative 3. Okay, for exponential function, okay, differentiate exponent is easy actually. Differentiate exponent, you have that your exponential function, okay, but it multiply with constant a. Sorry, or constant a. Okay, so it's time with constant a. Then we have a. You just copy back your exponential terms, exponent ax. For example, if you have exponent cx, differentiate exponent cx is exponent cx, but we time with 6. Exponent negative 4x, okay, is exponent negative 4x times with negative 4. Okay. Number 2, okay, this is alternative way, okay. Differentiate exponent to a function of x. Okay, differentiate exponent to a function of x. Okay, in alternative way, we have this formula. So this equal to exponent of x multiplied to f prime x. Okay, so exponent x squared. Okay, this is not a single function. Okay, we call this as a composite function. What is composite function? There's another function in a special function. So we have exponential and we have polynomial. Okay, so you call this type of equation as a composite function. Okay, this is a composite function. Okay, how are we going to differentiate this? Okay, we just copy. We know that differentiate exponent is exponent. Okay, but then we multiply with x squared. We differentiate x squared. So d dx x squared. So we have exponent x squared. Differentiate x squared is 2x. So we can simplify as 2x exponent x squared. Okay, similarly to the second example, exponent sign. This is composite function. Okay, exponent to a function of x. Okay, previously we have exponent to a single x. Okay, but for the second example here, okay, we have a composite function. So exponent to sine x. E to the sine x. Okay, so we have e to the sine x, but multiply to, you differentiate your fx. Okay, differentiate sine, we have cosine. So that's why you have cosine x exponent sine x. Okay. Okay, let's try exercise here. Okay, so, we have a few exercise here. Okay, so please try. Okay, can you guess? Y equal to negative 5. So what is y prime?
0.
Okay, good. Okay. Okay, so what about the second one? Y equal to x set e.
0.
Okay, good. Okay, so 1, 2, and 3, y prime is 0. Or you can write dy dx. Okay, dy dx is 0. Okay, 4 and 5 and 6 is types of polynomial. Okay, so let's find. Okay, what is dy dx?
3x
3x squared.
plus
Okay.
12x
Okay, very good.
minus 5,
Okay, so the last term is 10.
0.
Okay, very good. Okay, what about this? Y equal to x power to negative 9. What is dy dx?
negative x
Negative 9
and
Negative
negative 9.
9. Okay.
Negative 9x.
Negative 9
over x
Power
over
of
10.
power 2. Power
10.
2. Negative.
Negative power 10.
Okay, good. Okay, what about this one? Okay, so we have to rewrite this. Okay, so we have fx. Okay, so let's rewrite this. Okay, so set x is actually x power 2, 1 over
1
2.
over 2.
Yeah. Okay, so when we write the set x as x power to 1 over 2, then from here we know how to differentiate this, right? So what is f prime x?
Uh,
1 over 2 times 5 x power to
3 over
negative. Okay, negative half. 1 over 2 minus 1 is negative half. Okay, you can simplify this. So we have 1 over 2 x power to negative half. Or you can rewrite this. Okay. Okay, so for exponential function. Okay, can you please try? You have this material with you?
Mm,
oh my god.
No?
no.
Okay, okay. We will send this material to you. We try to send this material to you. Okay, so exponential. Okay, we right now we just copy. Okay. Okay. How to differentiate this?
Negative
Negative
6
16.
times 8.
Okay, y prime is negative 16 exponent.
Negative 2x.
Okay, negative 2x. Okay. Remember, there's nothing happened to exponential function. Okay, it's not minus 1. We just copy and paste our exponential. So it still remain as exponent negative 2x. Okay, because few students, okay, they use a polynomial rules, power rule to differentiate exponents. So what they have is negative 16 exponent negative x. This is so wrong. Okay, we cannot touch the power to this exponent. Okay, so I think they already sent to your email this material. So please check your email, okay, to get this material. Okay, why? Okay, question number 2. Okay, this is a composite function, right? Because exponent power to a polynomial equations, polynomial terms, 4x squared plus 5x. So do you still remember on how to differentiate these types of exponential function? So what is y prime? So y prime, okay, remember this? Okay, so when y is this, so y prime is f prime x times to exponent fx. Okay, so what we have, let's differentiate 4x squared plus 5x.
8x
Okay,
plus 5
okay, very good. And then multiply this.
exponent
Yeah, we just copy our exponential function. Okay, very good. Okay, so this is how we differentiate exponent, this types of composite function, exponent to the 4x squared plus 5x. Okay, so we can proceed, okay, for this example. Okay, it's quite tricky. So let's rewrite this x as y equal to exponent power to negative 4x. Okay, then from here, we know how to differentiate this, right? Okay, so we have negative 4 exponent negative 4x. Okay. Okay, we don't want to spend much time here. So let's proceed. Okay. Okay, so this is how we differentiate the logarithms. Differentiate ln ax is a over x. So differentiate ln x is 1 over x. Okay, differentiate ln for x is 4 over x. Okay, so that's why differentiate, okay. And differentiate ln to a function of x is f prime x over fx. Okay, the same technique. Okay, so differentiate ln x is 1 over x. Differentiate ln ax is a over x. Okay, so differentiate ln fx is f prime x over fx. Okay, differentiate ln 3x squared is, okay, differentiate 3x squared is 6x over to fx, or fx is 3x squared. So differentiate ln 5x plus 1. So first differentiate our function x. So we have 5 and divide with, we just copy fx, 5x plus 1. Okay, so you can refer to your worksheet. Okay. Okay, let's refer to our worksheet. Okay, so we have 3 ln x. Okay, so you know how to differentiate 3 ln x? 3
3
is a
over
part.
x.
Yeah, very good. Okay, differentiate ln x is 1 over x. So just multiply with a constant 3. So we have 3 over x. Okay, what about number 4? Okay, let's try to solve number 4. So what is y prime? Okay, you have the material with you, right? So you have the formula with you. So we copy 4.
6.
Because this is a constant. So how are we going to differentiate ln 6x?
6 over x.
Remember? Okay, very good. We have 6 over x. Okay, plus, what about ln 4x squared? How to differentiate this? Okay, how to differentiate this? What is the formula?
8x squared
x over fx. Okay, good. 8x squared over 4. Differentiate 4x squared is?
8.
X.
Okay, and then here we have 4x squared. Okay, please simplify this. So we have 12 over x. Okay, you can simplify this. Okay, so you can simplify this, right? What is the final answer again?
Log 12x. Log 12x plus log 2x.
Huh?
14
Pardon me?
x.
14 over x.
Okay, 14 over x. Okay. So in mathematics, normally we want you to write in a simpler, please simplify your final answer. Okay. So in order to simplify, you must know the basic skill, the basic mathematics skill. Okay, so trigonometrics is, okay, differentiate sign is cosine, differentiate cosine is negative sign. So when we have a constant ax, so differentiate to sine ax is a cosine ax, differentiate to cosine ax is negative a sine ax. Okay, differentiate a composite function to trigonometric sine fx, okay, equal to f prime x multiplied to cosine fx. Okay, it's quite similar to what we have in a single function. Okay, differentiate sine is cosine, sorry. Differentiate sine is cosine. Okay, but we have cosine of fx, so we need to differentiate fx. So we have f prime x times the cosine. Okay, we have this example. Y equal to sine to exponent. So this is composite function. So differentiate sine, we have cosine. Cosine to exponent to x. But exponent to x is a function of x. So we need to differentiate this. Okay, completely differentiate everything. Okay, differentiate exponent to x is 2 exponent to x. So this is the final answer. Okay, similar to cosine, differentiate cosine fx is negative f prime x sine fx, because we know that differentiate to cosine is negative sine, but now we have cosine of a function of x. Okay, so we have to differentiate fx to have f prime x. Okay, we have this example, cosine to this polynomial of second degree. So differentiate cosine is negative sine. We just copy our function negative sine to 3x squared plus 5. And then you differentiate 3x squared plus 5, you have 6x. So that's finally negative 6x sine x, 3 sines to 3x squared plus 5. Okay, so you can solve the slides in our worksheet. Okay. So let's proceed to technique of differentiation. Okay. Just now we differentiate a single function. Okay. Differentiate sine, differentiate cosine, differentiate a composite function. That's a singular function. Okay. When we are going to use this all techniques of differentiation. Okay. When you have a combination, okay, a product combination or a linear combination. So we start with derivative of sum and difference. Okay, differentiate. Okay, u plus minus v is differentiate separately each function. Okay, so differentiate u and differentiate v, where bear in mind here, for this example, for this formula, u actually a function of x and v is also a function of x. Okay, so we just differentiate each term separately. Okay, so let's just consider that you have a single function for each one. So we have this fx equal to 2x cubed plus x squared minus 1. Okay, the whole thing is polynomial, but let's consider this as a separate function. We have a cubic terms, we have a quadratic term, and we have a constant. So how to differentiate this? Yeah, that just differentiate each term separately, okay, with plus and minus. Differentiate 2x squared is 6. Okay, let's differentiate the first term. So we have 6x squared, okay, and then we have plus. Differentiate x squared, we have 2x. And then we have minus. Differentiate 1, so we have 0. But normally we don't write 0 in our solution, so f prime x is 6x squared plus 2x. Okay, similarly to example 2 and example 3. Okay, so the last example is quite complicated, right? There is a multiple types of function. So we have a rational function, we have logarithmic, there's exponential, there's trigonometric. So how are we going to differentiate this? We just differentiate this, each term separately, okay, and combine if negative and positive sign. Okay, so let's try to differentiate this because we don't have the solution to this, right? Okay, let's differentiate this. Okay, but before that, it's quite tricky. So let's rewrite this as 2 times to x power negative 5. Okay, so differentiate the first term is negative 10 x power to negative 6. Okay, differentiate ln for x.
4x.
Okay, negative 4 over x. Good. Okay, differentiate this 3 exponent negative 5x.
Negative 15e exponent negative 5x.
Okay, very good. Okay. Remember, we just copy and paste our exponential function, but we multiply with constant a times with a constant in front this. Okay. Okay, 2 sines 2x. Differentiate sign, we have,
4 cos 2x.
yeah, 4 cosine 2x. Okay, differentiate the last term is 0. Okay, and you can simplify this. Okay, this example is quite easy because we don't have a composite function. Okay, so product rule, when we have this, when we need to use this, okay, for a product rule, we use this technique when there's a multiplication of 2 or more functions. So for example, if our function x is a multiplication of 2 functions u and v, u of x and v of x, then how are we going to differentiate this? Okay, we have this formula, u prime v plus v prime u. Okay, so we have u prime v plus v prime u. So we let our first term as u and the second term as v, or randomly you can pick any. For product rule, you can pick anything because u times v is actually equal to v times u. Okay, but we have this formula u prime v plus v prime u. Okay, so we have this example. Let's differentiate this. Okay, so let's consider the first term here as u and the second term as v. Okay, if you practice more, you don't have to write this, but if for the first time, let's write u is 2x squared and let's write v as sine 3x. And u prime is 6x squared and v prime is cosine 3 cosine 3x. Okay, what's next? Substitute into the formula u prime v plus v prime u. So what's u prime? U prime is 6x squared. What is v? So cross multiply like this, right? Actually, times to sine 3x plus v prime is 3 cosine 3x and multiply to u, which is 2x cubed. Okay, so simplify this. So we have 6x squared sine 3x plus 6x cubed cosine 3x. Okay, so this is our f prime x. Okay, for second example, we have exponent 2x times 2 ln x. So like the first as u and the second term as v. So you can try to differentiate this. Okay, when we use product rule, when there is a multiplication of 2 functions, okay? For example, we have a function of polynomial for cubic terms like this, multiply to other function, a trigonometric. So there's 2 types of function, right? Okay, so how are we going to differentiate this? There's a technique. We have a technique to differentiate a multiplication of 2 functions. Okay, please remember this. Okay, when there's a multiplication of 2 functions, whenever you want to differentiate or to integrate or to find a Laplace transform, there's a technique, not simply differentiate the first term and just multiply to the second term. That one is totally wrong. Okay, a few students make this careless mistake. They just simply differentiate. They have 6x squared. They have the basic to differentiate equation, but that sine 3x is 3 cosine 3x. Okay, there's a few students differentiate f to multiplication function like this, and this is totally wrong. In mathematics, okay, remember in mathematics, when you have a multiplication of 2 functions, okay, you cannot simply differentiate or integrate each function directly. Okay, there is a technique. Okay, please bear in mind. Okay, when you have multiplication of 2 or more functions, you want to differentiate, you want to integrate, there's a technique. Okay, to differentiate or to integrate or to find the Laplace transform, for example, in ODE. Okay, cannot simply just differentiate each term separately and just multiply both. Okay, that one is totally wrong. Okay. Okay, so next quotient rule. So when we use quotient rule, okay, just now when we have a multiplication. So for quotient rule, when you have a division of two functions, okay, a function of x divide to another function of x. Okay, so we have this formula. Okay, u prime v minus uv prime or v prime u over v squared. Okay, for this example, you cannot simply pick u and v. Okay, strict rules, numerator is u and denominator is v. Okay, you cannot simply randomly choose which one is u and v. Okay, like for a product rule. For quotient rule, there's a specific rule. Okay, numerator must be chosen as u and denominator as v. And then you substitute into the formula u prime v minus v prime u over v squared. Because we have negative sign here. That's why I cannot simply pick u and v randomly. Okay, numerator is u, denominator is v. Okay, so we have this example. Okay, x power to negative 3 plus 2 over 3 cosine 4x. Okay, so how are you going to differentiate this? Okay, this is division of two functions, so we use a quotient rule technique. Okay, so let u, numerator is u, so u is x power to negative 3 plus 2, and v is our denominator, 3 cosine 4x. Okay, let's define u prime. U prime is negative 3 x power to negative 4. And what is v prime? V prime is negative 12 sine 4x. Okay, remember differentiate cosine is sine 4x, but there is 4. So multiply with 4, we have negative 12 sine 4x. Okay, let's substitute into the formula u prime v. So u prime is negative 3 x power negative 4 and v is 3 cosine 4x minus v prime. So v prime is negative 12 sine 4x times u is x power to negative 3 plus 2 and it's over to v squared. What is v? V is 3 cosine 4x squared. Okay, so you can simplify this. Okay, use your basic mathematics skill to simplify this. Okay, you can try second example. So let numerator as u and denominator as v. Okay, and then define u prime and v prime, substitute into the formula. Okay, that's it. Okay. Okay, class?
Okay, madam.
Okay, thank you. Okay, let's practice. Okay, let's practice. Okay, look at your worksheet here. Okay, technique of differentiation. Okay, the first one is easy. Okay. Okay, let's try exercise 1.2.2. We already done with this example. Okay, so let's pass it to solve this exercise 1.2.2. Okay, now we have a quite complicated, okay. So we want to find the derivative of the following equation, okay. Okay, can guys please find, okay, how are you going to differentiate this? What is the technique? So since there is a multiplication of two functions, okay, because obviously, okay, we put a bracket. Okay. So there's two brackets. So obviously you see that there's a multiplication of two function. Okay, so let this define here. U prime, sorry, okay. U prime is, let's say the first term as U and the second term as V. So let's straight away to differentiate U. So we have 3x squared plus 14x. And what is V prime? What is V prime?
Three cos 3x.
3 cos 3x. Huh? No, this one. 2 over x cubed.
-6.
Okay, very good.
-6.
Negative 6 power x power 2.
-4.
Okay, negative 4.
-4.
Differentiate exponent to x is 2 exponent to
X.
x. Okay. So what is the final answer? What is y prime? Plus v prime. Okay. So this is y prime. You can try to simplify or you set this as your final answer. Okay. So let's proceed to quotient rule. Okay, exercise 1.2.3. Okay, here we have a division of two functions. Okay, so let's try which equation you want to try. Okay, let's try question 4. So remember, for this, for quotient rule, you cannot simply randomly pick u and v. Okay, there's a strict rule. Numerator is u and denominator is v. Okay, so let's define u prime. Okay, what about this? How you define u prime?
3x
Huh?
u prime, is it?
Yeah, u prime. Yeah, for this one.
Punca kuasa 2
Yeah.
kedua tu.
Okay. Okay, for this thing, okay, you remember x power n is, okay, differentiate. Okay, differentiate d dx x power n is n x power n minus 1. What about you want to differentiate to fx power to n? Okay, similarly, okay, can you guess what is the formula? Okay, so we have n, and then we just copy our fx, and then n minus 1, and then, can you guess what is the formula?
Oh, so nanti dapat 2
Yeah,
in
2.
bracket,
Yeah, we just copy what we have in our bracket, and
then
then
2 minus 1.
2
So
minus 1 is 1.
1.
But the formula is not complete. You must multiply with f prime x.
Differentiate.
Yeah, good. Differentiate f prime. Okay. And then, so that means it multiply with 3x squared minus.
It's 4x.
Okay, good. Okay. Please copy this formula. Okay, we know this rule. X power n is n times x power to n minus 1. What if x now is a function of x? So fx power to n. So similarly, we multiply n to the front and then we just copy fx and the power is minus 1. But remember, since we have fx, we have to differentiate completely. We must completely differentiate everything. So multiply with f prime x. Okay. Okay, so now we let U is Gx and Y is Fu. Then the composite function of G and Y is Y equal to Fu equal to F composite of Gx, and we have this formula dy dx is equal to dy du times du dx. Okay, how to prove this? Is it dy dx equal to dy du times du dx? Okay, see, we can cancel out du and du. So what's left is dy dx. So that's why dy dx is dy du times du dx. Okay, just to double check, okay, our formula if you forget. Okay, dy dx equal to dy du times du dx. So let u is a function of x and y is a function of u. Okay, we must start with this. Then our composite function of g and f is y equal to fu. So now we have f is a function of g. Okay, so we have this example. We want to find a derivative to the following function. Okay, we actually have the alternative way right just now, right? How to differentiate this, but there is other technique. Okay, we can use a chain rule technique to differentiate this. So how? It's quite complicated, but let me show you. Okay, u is a function of x. So what is u? So we choose u equal to 2x squared plus 1 minus 3. Oh, sorry. Minus ln 3x. Remember, we note that u is a function of x. Okay, for chain rule, okay, there's a technique. You must select which term to be u. Okay, now u is function of x. So let's consider, okay, what we have in bracket as u. So we have u equal to 2x squared plus 1 minus ln 3x. Okay, now, so u is a function of x. So this one is correct. Okay, what is y? Y is a function of u. So y is u squared. Right? Since we consider what we have in bracket is as u, so y is u squared. So what is dy du? Differentiate y in terms of u, then we have dy du is 2u. What is du dx? Differentiate u with respect to x, we have du dx. So 4x plus 0. Differentiate negative ln 3x is?
3 over x. Negative 3
Okay,
over
negative
x.
3 over x. Okay, now let's substitute. We have du dx, we have dy du. Let's substitute into the formula here. Okay, so therefore, dy dx is dy du multiplied to du dx for x minus 3x. This is not the final answer. Why? We already substitute everything in the formula. Why is it? This is not the final answer. Can you guess why?
Sebab ada u tu.
Okay, very good. Because we have u. What is u? Okay, our problem is a function of s. Why suddenly you come up with the solution with u? So remember to change back u in terms of x. So dy dx is 2. Okay, 2 times u. What is u? U is 2x squared plus 1 minus ln 3x. Okay, times to 4x minus 3 over x. Okay, so this is when we use a chain rule to solve this problem. But just now, I already give you the formula, right? The alternative way to differentiate this. Okay, so we have fx power n. Okay. Oh, what saya tulisan ni? Times n, we just copy our fx and power minus 1 and multiply with f prime x. Okay, similarly, we can get the same solution. Okay, in the faster way. Okay, so you can proceed to solve this example. Okay, after this, so let's move to the next slide. sorry. Okay, so we don't have next slide because next slide is integration. Okay, so let's practice. Okay, let's do some practice on this technique. Okay, so we have this. Okay, so can you please practice how to differentiate number 2? So we have cosine 2x plus 3x plus negative x, and the whole thing here is power 2. Okay, so please.
Pakai apa-apa method pun boleh lah, Madam.
Yeah, the easiest way is we actually can directly input this. Okay, so
Negative 4 sine 2x.
negative 4 sine 2x. You solve which problems?
Salah, Madam.
You write the you okay, you read the final answer. Okay, thank you. Okay, you read the final answer. You have negative 4 sine 2x, and then okay, so let's differentiate this together. So we times 2, and then we just copy and paste what we have in bracket. Okay, what happened to power 2? So we minus 1, and then let completely differentiate what we have in bracket. So differentiate cosine 2x is negative 2 sine 2x, and differentiate 3 exponent negative x is negative 3 exponent negative x. Okay, and then you can simplify this. Okay, please simplify this. That's why we have negative 4 sine 2x minus 6 exponent negative x. Okay, it's multiplied to cosine 2x plus 3 exponent negative x. Okay, so you can practice on exercise 3. It's quite easy, question 3. So please. Okay. Someone please help me to solve to find f prime x.
20.
Okay, there's 20, and then
x 3 plus
okay,
6x minus 3
negative 3.
okay,
power of 9.
Power of 19.
okay, very good. And then
3x
Bracket
multiply
3x
okay,
squared.
3x plus 6
plus 6. That's it. Okay, so this is the final answer. Or you can simplify. You can multiply 20 with things in the last bracket. Okay, Remember, you cannot times 20 to this bracket because it's power to 19. Okay? We cannot simply insert anything into this bracket because it's power to 19. Okay, when this bracket is okay because it's power to 1, you can just easily open the bracket. Okay, so 20 can multiply to 3x squared and 20 can multiply to 6. But you cannot multiply 20 to those in the first bracket because power to 19. Okay, what about the last example here?
Three
Okay.
minus 2x.
Okay.
Power of
Power
1
of
over 2.
1 over
Okay,
2.
very good. Okay, very good. Let's rewrite this first as 3 minus 2x power 1 over 2. Okay, because when we have this, sometimes we have no idea how to differentiate this. Okay, when we have a third sign like this, 3 minus 2x. Okay, so we know that we can rewrite this as 3 minus 2x power to 1 over 2. And from here, we know that we can easily differentiate this by power rule. So we have 1 over 2, we just copy and paste what we have in bracket, and power minus 1, negative 1 over 2, and differentiate what we have in bracket, negative 2. Okay. So we can simplify this. So the final answer is negative 2 set 3 minus 2x. Okay, it's quite easy, right? Because all this is type of polynomial. Okay, it's not polynomial, sorry. A power rule like this. Okay, what if we have extra exercise? Look at this extra exercise. Okay. You think how we're going to differentiate this? Okay. We have to combine all the technique that we have learned before. Okay. Because we don't have a single function here. Okay. So there's a function multiplied to other function. Okay. Can you suggest me what is the technique to differentiate the first equation? Product rule. Okay.
Chain rule.
Chain rule, product rule, and also
Question.
there's a combination. Okay, product rule because we have a function multiplied to another function of x. But in order to differentiate the first term here, we apply a chain rule, right? Okay, so now let's differentiate this. Let's try to, okay, the first u is x squared plus 5 cubed, and b is 4 minus x squared power 4. So what is v prime? Okay. Okay, first we applying product rule. That's why we present u and v. And then we want to find u prime. In order to find u prime, so from here we apply a chain rule technique. Okay, a chain rule or this alternative. So we have 3 times x squared plus 5 power 2 times the 2x, right?
Yes.
And v prime is 4 minus x squared power 3 and times to negative 2x. This is not the final answer. U prime v plus v prime u. But first, let's simplify our u prime 6x. Okay, remember you cannot simply multiply 3 to the first bracket because of what? Because first bracket is power 2. Okay. Okay, what is v prime? Let's simplify v prime. Negative 2 times 4 is negative 8x. 4 minus x squared power 3. Okay, there is square here. Sorry. Okay, so let's write the final answer. Y prime. So y prime is u prime v plus v prime u. So 6x. u prime. This is u prime. So what is v? V is 4 minus x squared power 4 plus v prime is negative 8x and v prime and u is x squared plus 5q. Okay?
Okay.
Okay. Can you please try question 3? Okay, what about question 3? What is the technique?
Got product eh?
Yeah, product.
Product.
Okay.
Chain. Same
Okay.
as before.
So what is u prime?
Nine X.
No.
Let's solve it here. Okay, so like the first term as u and the last term here as v. So u prime is 9x squared. And what is v prime? We have a composite function. Cosine.
4.
4 cosine for x multiply to
Exponent.
exponent sine.
Sine
Right.
for
So okay,
x.
remember, we actually applying this rule. Okay, we differentiate d dx of exponent of this composite function. So we have f prime x times exponent fx, right? Okay, that's why we have this. Okay, f prime is x 4 cosine for x. Okay, exponent, so we have exponent. Okay, so u prime v plus v prime u. So 9x squared times u, times v plus v prime is 4 cosine 4x. So we can simplify this. For cosine 4x. Can you simplify this? Okay, 4 and 3 constant, so we can combine 4 and 3 as 12. Okay. So we just can combine 4 and 3 as 12. So we have 12 here. Okay, that's it. Okay, remember, we cannot simply times 4x with x cubed here because this is part of trigonometric function. Okay, bear in mind. Sometimes if a student make this mistake, cosine 4x times x cubed. Okay, they have, okay, how come you can write 4x power 4? This is so wrong. Okay, cosine 4x times x cubed is always equal to x cubed times cosine 4x. We just can move x cubed to the front. So, but we cannot multiply x cubed to 4x because this is part of trigonometric function. You cannot simply, okay, go into the trigonometric function. Okay. Okay, what about question 5? It's quite complicated. Do you have any idea on how to differentiate this? Last exercise.
Yeah, to do with quotient rule.
Okay, so use the quotient rule and combination techniques. Okay, okay, you want to use quotient rule. Okay, remember, cannot simply pick u and v. Numerator must be u and denominator is v. So that means u is sine square x and v is cosine 2x. So what is u prime? Okay, let me differentiate with v. So v is negative 2 sine 2x. Okay, now you guys please differentiate sine square x.
Negative 2
Negative 2
cos
cos negative 2 cos negative 2 cosine. Stop pula dah. Okay, you can write u as sine x squared. Okay, now if we have this, you know how to differentiate this? Because we rewrite sine square x as sine x squared. Now, if we have this type of equation, can you differentiate this? Remember this technique? When we have fx power n, this is actually equal to n, and then you copy what you have in bracket, n minus 1, and f prime x. Okay, now, let's differentiate this. Okay, so we have 2,
x
okay,
negative cos
negative cos, sine,
times cos x.
positive cos. Okay, okay, so what's the final answer? Y prime. This is u prime. So what is your v? Cosine 2x. And then minus
U, V,
u. And it's over to
V, also power of 2,
okay. Cosine 2x
power of 2.
squared. Okay. Can you simplify this? 2 sine x cosine 2x. Can you simplify this?
Can.
Okay, so if you can simplify, what is the answer? Can or cannot?
Madam, kita boleh buang cos 2x tu kan?
Nak buang macam mana? Dengan bawah ni?
Ha.
Tak boleh mati. Tak
That
boleh.
cannot, okay? You cannot do this. Okay, careless mistake. Okay, a common mistake student made. Okay, because you see there is cosine 2x in numerator and there's another cosine 2x in denominator. Okay, you think that you can simply cancel it out? No. Okay, you can cancel it out if both terms in your numerator have cosine 2x. Okay, if both terms here in your numerator have cosine 2x, so first you have to cut out cosine 2x. And then you can cancel it out with denominator. Okay. In this case, since only first term have cosine 2x, but the second term there is no cosine 2x, we cannot cancel cosine 2x. Okay. Okay.
Okay.
Okay. Okay. We cannot simplify this. Okay. This is the final answer. 2 sine x cosine 2x. We cannot do anything. Cosine x cosine 2x. Okay? But we can simplify with positive sign, only with positive sign. So we have 2 times 2x sine square x. That's it. Okay. Okay, although we have sine and sine, we cannot combine this. Okay, that's it. Okay, so you have any question? I think we have our end of the question. Part 1, differentiation. Do you have any question? Regarding all the techniques?
I think understand now. For
So you can practice, okay,
alright.
this worksheet. Okay, so please. Okay, so you have to fill in survey, if I'm not mistaken. Before we proceed to next session, you have to fill in a survey. Okay, you have any question? You still have 2 minutes before you proceed to integration. Okay, I really hope that you have this, okay, with you, okay, your worksheet, okay, so you can recall back all the basic mathematics, okay, all the logarithm and indices, trigonometric function. You can refer to this when you solve ODE exercise, okay, or applied calculus exercise, okay. It's very useful, okay, to recall back all the basic mathematics, okay. Okay, if you have no questions, so I think I stop here. Okay, so we'll proceed with integration session. Okay, so look at the chat. Okay, you have to fill in the survey. Okay, that's given by Madam Nur Hafizah Muslim. Okay, so thank you, class. Okay, so
Thank you,
please
madam.
stay because we have another session with other lecture. Thank you.
madam. Thank you, madam.
Thank you, madam.
Where is the survey?
Thank you, madam.
Thank you, madam.
Thank you, madam.
Thank you, madam. Thank you, miss.
Thank you, madam.
Boleh dengar suara saya?
Slow, madam.
Okey, boleh dengar Boleh dengar? Kalau boleh saya akan proceed, boleh Okay, so we will start our second session. Okay, integration. So gentle reminder, first of all, please mute your microphone. But if you have any question or if you want to respond, okay, you can unmute your microphone. All right. Okay, so next we will look at integration. Okay, integration. So before that, let me introduce myself. So I am Nadira Muhammad Nasir. Okay. So this Back to Basic organized by Center of Mathematical Sciences. Okay, under.
Medium, suara medium slow sangat.
Oh, tak dengar?
Kurang jelas.
Dengar, madam, tapi slow.
Okay, boleh dengar tak? Sebab saya pakai headphone ni. Clear or not? Can you hear me?
Can, madam, can.
Oh, okay. Boleh Okay, so we will look at integration. Okay. Okay, so this is our expected outcome from this session. So we hope that on this discussion, okay, a student can enhance their understanding on the basic integration, okay, and also on how to use integration techniques, okay, because we found out that many students, okay, most of the time have a difficulties to integrate correctly. Okay, so what is actually integration? Okay, so what is actually integration? So tadi previously you learned about differentiation. Okay, so integration is actually the reverse process. Okay, the reverse process of integration or inverse of integration. Inverse of differentiation. Okay, so you can see here, we have the word here, inverse of differentiation. All right. So if you differentiate, you have the solution of your differentiation. That solution, if you integrate, you may get back your differentiation. Okay, so it's a reverse process. Okay, as I note here. All right. Okay, so if you integrate back your what we call output of your differentiation, okay, then you will get back the function. Okay, for example, okay, simple example. Let's say we have, okay, previously you have fx equal to x squared, okay, for example. Then you differentiate. Okay, tadi you have learned on how to differentiate. So differentiate f prime x square, what do you get? Dapat apa ni? Differentiate x square.
2x.
Okay, very simple. You should get 2x. This what happened in differentiation. All right. So if I do the reverse process, okay, I do the reverse process means that I integrate. Okay, I integrate with respect to our variable. So variable, of course, x, dx. Okay, we integrate with respect to dx. So what we get here is we get 2x squared over 2 and then plus your constant. Okay. So actually here we have a constant where constant can be any value. 0 also constant. So in this case, C0 lah previously. Alright. So this will give you x squared plus C. Okay, x squared plus C. Means that we get back what we have here. Okay, so that's why integration is the inverse of your differentiation. Okay, so itu idea basic dia. Kalau saya laju ataupun if I'm too fast, okay, if you want to ask anything, so you may interrupt. Okay, we do the two-way communication. Okay, so let me share again, okay, revise on the basic integration formula. So basically we have indefinite integral and also definite integral. If your integration without limit, okay, you look here, without limit, we don't have the value of lower and upper limit, then we call as indefinite integral. Okay. Okay, for example here, we have a standard or general formula here without limit. Okay, we don't have a lower and upper value. All right, the first one, if you want to integrate, very basic one, integrate 0 dx. All right, integrate 0 dx is actually you get constant, okay? Where C can be any real number, any values. All right. Okay, I believe that this is not too difficult, okay, for this table. All right, this is a standard integration formula. Okay, so if you have a constant multiply with your x, okay, so x here is your variable. So if you integrate kx, you may get, sorry, this should be integrate k, okay, this should be integrate k, okay, there is a mistake with this table. So if you integrate any constant, you should get kx plus c. For example, if you integrate very simple one, 2 dx, okay, you should get 2x plus c, okay. So this is very simple one, okay. You cannot do mistake. It's a very basic integral. Okay, let's say you have a power. Okay, the next one, you have x power n. Okay, x power n. So how we integrate x power n dx? All right, so since integration is a reverse of differentiation, in differentiation, okay, previously in differentiation, if you dx your xn, okay, what you did is the power you multiply in front and then you minus your power with 1. Okay, so this is what you did in differentiation. The reverse process for integration, okay, the reverse process for integration, we start with you plus your power with 1, okay? So you plus your power with 1 and then you divide your power, okay? You divide your power and then you plus with constant, okay? So every time if you deal with indefinite integral without limit, so you must plus constant, okay? If you not write plus constant, so your solution is not accurate. Okay, tidak tepat. But if you have limit, then you insert the limit. Okay, we will look later on. All right. Okay. So we have a note here where n not equal to -1. Okay, where n not equal to -1. Because for n equal to -1, we have a very special integration which is belong to ln. Okay, belong to ln. Okay, so you look here. Okay, this one is actually, if I rewrite this, okay, it's actually, if I rewrite this is integrate 1/x dx. Okay, this is also integrate x power -1. Okay, x power -1. So that's why we have the information here. This formula not applicable when n equal to -1. Okay, why? Because if your power -1 and then you plus 1, you may get 0. Okay, you get 0. Then how can you divide with 0 here? Okay, so that's why in this formula, n cannot be equal to -1. Okay, because if n equal to -1 here, if you integrate, you should get ln absolute x. Okay, we put the absolute because we want the value to be positive. Okay, ln cannot be negative. Okay, ln must be positive. All right. Okay, that's why we put the absolute sign when we write our ln. Okay. And then this is also a standard one. Okay, very common integration. And then we have okay, for exponent is very special. You may get back your exponent, but you must to divide with the power of your exponent. Okay, differentiate the power of exponent. Okay, so I believe that this table is very clear. Okay, so far, okay. Okay or not with this table? Okay, this is very basic. Okay. Okay, so let's look at example. All right, before we go to example, I have another rules in integration. Okay. This is one important tips. When you solve your integration, okay, it's good to simplify your integration by bring out your constant. Okay. If you have your function inside your integration, then you can factorize your constant. In order to simplify the integration, you bring out the constant. For example, okay, for example, you have integrate 3x squared plus 6 dx, for example. Okay, so I can also write this as integrate 3x squared plus 2 dx. Then I bring these 3 outside. Okay, so I have 3 outside here and then integrate x squared plus 2 dx. So you can see here, it's quite simple. Okay, if we were factorize our constant outside. Okay, so you can use this technique rules here. Okay, to simplify your integration, but make sure that you able to factorize and then the constant you bring outside. Okay, you cannot bring the variable, you cannot bring the x outside because x must be integrate because x is the integrand. Okay, we also have these properties here. If you have two function, okay, you want to integrate fx plus another function gx. So you can split, okay, you can split into 2. Okay, you can split into 2 your function. Okay, it's a plus minus. Okay, you can split. Okay, so this is also if you have what we call a constant outside. Okay. Okay, that what I show is a indefinite integral if you don't have the limit, lower and upper limit. However, if you have lower and upper limit, you must to insert the limit. Okay, so remember, this is our upper limit. Normally, upper limit, the value bigger than lower limit. Okay, nilai upper lebih besar pada nilai lower. Okay, then you want to substitute you insert the upper limit first and then you minus the lower limit. Okay, we will look at example. Okay. So let's look at this example. Very simple one. Okay. Okay, I believe that A, no problem. Can you tell me what is the solution for A? Integrate 5 dx. What you should get?
5x plus c.
Okay, good. It's very simple. Okay. Student, you are an engineering student, you are a degree student, you cannot do mistake for this very simple integration. Okay. So it's just 5x plus c. If you have limit, then you insert the limit. Okay, I believe that B also very straightforward. Okay. Can you try C? Can you try C? What we get for C? Integrate exponent 2x plus 5 exponent negative 3x. Can you tell me what is the solution? You may try. Integrate exponent. What we get for C? So for C, if you integrate, okay, if I split here, plus, then I factorize my constant outside. Okay. So integrate exponent 2x. What do you get? Dapat apa?
2 exponent 2x 2 exponent
Okay, Aina, be careful because when you do the integration, you not multiply the power. You must do divide the power. That is the reverse process. Okay, it means that this should be exponent to x over 2. Yes, we divide with differentiate 2x. Okay, kita akan divide dengan differentiate the power of your exponent. Alright. Okay, then what we have here? Okay, so plus 5 exponent negative 3x and then divide with what?
3.
Negative 3. Be careful. Be careful. If you have negative, you should have negative. Alright. Okay, negative 3. Okay, plus constant. And then you can simplify this lah. Exponent 2x over 2 minus 5 over 3 exponent negative 3x plus c. Okay. Okay, the last one before we proceed. D. Can you try D? Can you try D?
Yes.
How to integrate D? Can you simplify the function first? Can you simplify or not?
Can.
Okay. So how? We
Right.
Okay, we divide with x for both numerator. Okay. Selalunya, okay, mistake. Okay, let me highlight the common mistake first. Okay, let me highlight the common mistake first. Look at D. For D, you want to integrate 1 plus x over x dx. Okay, student, remember, if you have a fraction, okay, this is a fraction. If you have a fraction, you can separate the the denominator for both terms. Okay, so we can separate like this. 1 over x plus x over x dx. Okay, then you simplify your function first. So that is easy for you to integrate. Okay, so this will give you integrate 1 over x plus integrate 1 dx. Okay, here also dx. Then integrate 1 over x. Remember, you should get ln absolute x. Okay, and then integrate 1, you should get x. And then plus with
C.
Okay, good. Okay. Selalunya kesalahan pelajar, okay? Kesalahan pelajar, this is a very serious mistake. Sebagai contoh, if you have integrate x over 1 plus x dx. Okay, this is a very serious mistake. Okay, yang student selalu buat ialah dia pergi pecahkan walaupun you separate your denominator, you pergi buat integrate x over 1 plus x over x. Okay? Student, this is totally wrong. Okay? This is totally wrong. If you have a fraction, you only can separate the term for denominator only. Okay, means that numerator you can separate and then you divide with the single denominator. Okay, this is the right way. Okay, however, if you have in this form, you cannot simply write in this. Okay, this is wrong. Okay, this is wrong. Okay, bear in mind because student always do this mistake. Okay, so I believe that this is very simple. Okay, if F also same. Okay, trigo, please try. We try first. Trigo, what do you get? Kita tak ada lagi example trigo. Can you try this? What you get this? 4 sin x. Let me check the material first. If we have integrate trigo, or we don't have integrate trigo here. Okay, we have the integrate trigo. Let's look at this one. 7. Can you tell me what is the solution? Okay, can you try? Integrate 8 sin 3x dx. What is the solution? Integrate sin 3x. You should get what? Cos x, negative cos x.
Negative cos 3x.
Okay, negative cos 3x. Then you need to multiply or you need to divide with the term inside your sign.
Over 3.
Over 3.
Over 3, good. Okay, student, look here. So I can factorize this. Okay, so 8 integrate sin 3x dx. Okay, wait. So I can factorize this 8, okay, integrate sin 3x dx. All right. So remember, student, integrate sin 3x here, you should get negative. Okay, so negative cos 3x. Okay, but remember you must do divide. Divide with differentiate 3x. Okay, in differentiation we multiply the value of 3, but in integration we divide with differentiate 3x. So you should get here 3. Okay, and then plus constant. All right. So if we simplify this, negative 8 over 3 cos 3x plus c. Okay. Okay, so I believe it's enough for basic part. Okay, boleh setakat ni? Can you follow me? Okay, boleh? Okay, student, boleh setakat ni?
Boleh.
Okay, good. Okay, so I leave it to you, exercise 1. Okay, this is very straightforward. Just the exercise for you to recall back your understanding on integration. Okay, so I also give you another exercise here, okay, together with the answer. You may download these materials from your email. Okay, we already emailed you all the materials. Okay. Okay, look at your screen now. This is a very biggest mistake that students always make when you solve integration. Okay, Tak kisahlah first year student, second year student, third year student, final year student, you always faced with these mistakes. Okay, let me highlight here. Okay, so if you look here, if you have a function, okay, if you need to integrate two function, multiplication of two function. Okay, let's say we have, you need to integrate x square multiply with exponent x dx. Okay, so integrate x square multiply with exponent x dx is not simply equal to integrate x square multiply with integrate exponent x. Okay, this is a big no. Okay, this is very wrong. Okay, wrong mistake. It's a very serious mistake. Okay, you look here. If you have two function, okay, for example, polynomial multiply with exponent, you cannot simply split these two function and then you integrate and then you multiply. Okay, this is wrong. And then we have another mistake also. Sometimes students simplify like this. Okay, you have two function and then you bring one function outside, like you factorize your function and then you just integrate gx. This is also totally wrong, okay, because we don't have these properties. Okay, and another serious mistake is like this. Okay, if you have two function, then you simply split these two function and then you make it as a divisor. Okay, for example, let's say you have integrate x squared plus 3x over exponent x. Okay, for example, then you just let it become integrate x squared plus 3x over integrate exponent x. This is also a serious mistake. Okay, this is also a serious mistake. We don't have this rule. Okay, we don't have this rule in integration. So how to evaluate this integration? When you have multiplication of two function, when you have quotient of your two function, so we have technique of integration. Okay, remember when Dr. Rosie explained about differentiation, okay, you have a differentiation rule, you have product rule, you have quotient rule. When you use product rule, when you have two function multiply with, you have two function, a multiply of two function. Okay, when you have x square multiply with exponent x, and then you want to differentiate, you use product rule. So same like integration, when we have multiplication, we have a technique of integration. Okay, if you have in differentiation, if you have exponent divide with x square, exponent over x square, for example, you want to differentiate, so you can use quotient rule. You have a rule, quotient rule. So similar with integration, when we have two function like this, okay, so we also have a technique of integration. Okay, technique of integration. So we need to evaluate using techniques of integration. Okay, so let's start with the first technique of integration, integration by substitution. Okay, integration by substitution. Okay, look here. Okay, so there is a step here. Okay, step by step on how to implement technique of integration. Okay, so in order to use technique of integration, you must to decide. Okay, you look at the function, you must to choose the function that you can differentiate, and then after you differentiate that function, you can write in the rest of the term. Okay, I will show you later. Okay, So suppose u is a differentiable function of x, then if you want to integrate fu du dx dx, okay, it's also simply equal to integrate fu du. So in integration by substitution, the first step, you must select your function u, okay, so that you can find the derivative. You can differentiate that function u, okay. And then after that, from that u and also du dx, you can replace back into your original function so that you can simplify the function, and then you integrate the simplification that you did, okay. And then after that, you integrate. After you do the integration, you evaluate. So at the end, you must to replace back what you lack here, okay. You must to replace back what you lack at the first step, okay. Kita tengok example, okay. Kalau kita cerita, if I say step by step ini, maybe it's difficult to digest. So let's look at example. Okay, for example, this one, okay. You ask to evaluate integrate 5x plus 3 power 7, okay. In this case, if you're good at expand your function, okay, you can do so. You can expand and then you can integrate. But student, you look here. This function is power 7. Okay, saya pun tak boleh nak expand dia power 7. Okay. So alternatively, we use technique of integration. Okay, by substitution. Okay, look how we use technique of integration by using substitution. Alright. So integrate 5x plus 3 power 7 dx. Can you tell me which term we need to let as u? Okay. So you need let u apa dia? Can you tell me? What should we let as u? Inside bracket or the power? Let u 7 or let u 5x plus 3? Which one?
5x plus 3.
Okay, 5x plus 3. Okay, of course, we need to let function that we can differentiate. Okay, if you let u equal to 7, you differentiate 7, you get 0. Okay, so you must to choose a function to be your u. Okay, so first we let u equal to 5x plus 3. Okay, student. And then we differentiate u with respect to x, okay, because our variable is x here. Okay, so you differentiate u with respect to x, so you should get 5. Okay, you should get 5. And then you look here. We want our dx here. Okay, we want the term of dx here. So we make a rearrangement here. Okay, we make the arrangement. So if you rewrite this, you may get 1 over 5 du equal to dx. Okay, am I correct? Correct or not? Okay, setuju eh? Okay, so now we substitute in term of u. Okay, we substitute in term of u. So integrate 5x plus 3 power 7 dx. Okay, so student, we already let this as u. So here we have u, all right, power 7, okay. And then what is your x? Okay, the x is actually 1 over 5 du. Okay, so remember, if you make a substitution, okay, you let in term of u. When you want to integrate, you substitute in term of u. Everything must change into u. Tak boleh ada lagi x. Okay? You cannot have x anymore when you make a substitution. Alright? So from here, okay, so to simplify, I can factorize this out. So I have 1 over 5. So I just need to integrate u power 7 du. Okay, integrate u power 7. What do you get? Dapat apa integrate u power 7? Okay, integrate u power 7 du. So what you should get?
U8 divided by 7.
U power
U
Eight.
power
8. U8 divided by 7.
divide by 7
divided by
pula.
8.
Okay.
Sorry. Divide 8.
Okay. U power 8 divided by 8. Alright. Remember, power plus 1 divide with power. Alright. So what you get here? 1 over 5. U power 8 over 8. Okay, don't forget your C because this is also indefinite integral. We don't have limit. Okay. So if I multiply, I should get u power 8 over 40 plus C. This is our solution? Should we stop here or we need to substitute back?
Substitute back.
Okay, you need to substitute back. Okay, because the original problem is x. Okay, soalan asal ialah x. Okay, so don't leave it like this. You must to substitute back your u. What is your u? Okay, so you substitute back your u here. Alright, you substitute back 5x plus 3. Okay, this means that our solution should be, okay, our final solution should be, okay, the correct solution is 5x plus 3 power 7 dx. So we substitute back, so we should have 5x plus 3 power 8 over 40 plus 3. So this should be your solution. Okay, all right. That is one idea when we use integration by substitution. Okay, especially when you have a very highest power. Okay, for example, here you have power 7. Okay, all right. Okay, let's look at another example. Okay, example 2a. Okay, look at this problem. Can you tell me? Okay, try to figure out the solution. Okay, cuba buat. Okay, if you want to let u, which term you must to let u? Can you tell me which one should be your let u?
X squared plus 1.
X squared plus 1.
Okay, why you choose x squared plus 1 instead of 2x? Why you choose let u equal to x squared plus 1, not 2x? Why?
Because it has a power.
Sorry, because highest power.
Power, yeah.
Okay, lagi? Another reason? Why? Why you choose u equal to x squared plus 1? Okay, so remember, as I told you, when you decide your u, and then you differentiate that u, you may represent the rest of the term. Okay? Baki yang tinggal itu. So, if I let u equal to x squared plus 1, okay, then I can have du dx equal to 2x. Okay, so remember, by let this as u, you look here, if I let this as u, I can have another term here to be right in term of u. Okay, in term of u. You, not me, in term of u. All right. Okay, so if I rewrite this, I can have u x dx in term of u. Okay, so that is one tip. Okay, how to decide the selection of u. Okay, so now what I have here is, if I rewrite in term of u, okay, so I have integrate x squared plus 1 squared 2x dx. So what I have here, this is actually u. Okay, so I should have here integrate. Okay, so now this become u square. And then what is actually 2x dx? Okay. Baki dekat situ, I can write in term of du. Okay, so now it's easy for us to integrate. Okay, so now you just need to evaluate the u square with respect to u. Okay, so what do you get here? If you integrate u square with respect to u, you should get u power what?
3.
Okay, u power 3 divided with
3.
3. Okay, good. And then plus c. Okay, but this is not our final answer because the question asks you about x, not u. Then you must to substitute back your u. Okay, so kita kena ganti balik dekat sini. Okay, you must to substitute back your u. So the final answer should be x squared plus 1 power 3 over 3 plus c. So this should be your solution. Okay. Let's say you choose wrong u. Okay, if I give you another another method or another solution, okay, if you choose this as u, okay, if you choose this as u, all right, why we cannot choose 2x as our u? Because if you choose u equal to 2x, okay, and then you differentiate du with respect to x, you get 2. Okay, you get 2. And then if you rewrite this, okay, you rewrite du equal to du over 2 equal to dx. Okay, so if you substitute back here, okay, you substitute back in term of u. Okay, saya padam dekat sini. Alright. If I use this as my leg u, okay, what I get here is I get u here. Okay, this term is my u. Okay, I have u here. And then I have my dx. Okay, dx is du over 2. Alright. But how about this term? Okay, I cannot represent this term. I cannot change this in term of u. Okay, I cannot change this in term of u. You may get here. Okay, you may get here x equal to u over 2. Okay, if you write here u over 2 square and then plus 1 square, then you can see here it's become more complicated. Okay, it's become more complicated. So that's why you must to select or decide the correct function to be your u. Okay, so the best u is actually u. When you differentiate, you can represent the other term. Okay, all right. So that is the tick for integration by using substitution. Okay, if I go to this material, let me choose another example. Okay, let's look at trigo. For example, this trigo. Okay, let's look at this. Let's look at question 7. Okay, student, can you tell me if you want to solve this by using substitution, so what should you let as u? Okay, how to start this? Can you try to figure out? Okay, how to, what should we let as u for this problem? Okay, boleh untuk soalan ni. So what should be your u?
2x square.
2x square. Okay, yang lain? Why don't you choose u as sine 2x square? Is it sine 2x square as your u?
I mean 2x square.
2x square, not sine 2x square.
Yes.
Okay. Why you choose 2x square only as your u?
I don't know.
Okay, okay. Selection tu dah betul. Tetapi I don't know pula. Alright. Okay. So, correct lah. You must to choose. Okay, you choose. As I told you, when you let your u, okay, u equal to 2x square. Alright. And then you differentiate your u, du dx. Okay, differentiate this, you get 4x. Okay, means that by let this equal to u, okay, and then kita boleh, we can have the rest of the term. We can have another term to be represented as u. Okay, so if I rewrite here, okay, I can have du over 4 equal to x dx. Okay, I can have x dx here. Okay, x dx here. So if I write in u, okay, in term of u, so what I have here is the integrate, okay, sine 2x square x dx. Okay, remember student, this is multiplication. If you have two functions, you multiply. So never mind, you can bring your function to the back, okay, because this is multiplication. Fx multiply with gx also equal to gx multiply with fx. So even though I have x in front here, but in order to rewrite so that it's clear for me to insert my u, so I can change the position. Okay, multiplication, no problem. Okay, fx multiply with gx equal to gx multiply with fx, means that a multiply with b equal to b multiply with a. Sebab tu kita kata 2 darab 5 sama dengan 5 darab 2. Okay, because that is multiplication. So no need, it's okay to change the position, okay, of two term in multiplication, two function in multiplication. Okay, so what I have here, if I write in a u, okay, if I write in u, so I should have here integrate. Okay, so sine, so you already decide this, okay, u equal to 2x squared, so this now become sine u. And then x dx, okay, what is your x dx? X dx is 1 over 4 du, okay. So this is constant, so we bring constant outside, so that is easy for us to integrate, to proceed with the integration. So 1 over 4 integrate sine u du. So what do you get? Integrate sine u du. Dapat apa? Okay, what do you get? Integrate sine u du. What should be the solution?
Cos u.
What?
Negative
Negative
1
cos
over
u.
4.
Okay. Remember, when you integrate sine u, you should get negative cos u. Okay, jangan lupa negative. So it should be 1 over 4 negative cos u, and then plus with c. Okay. However, this is not our final answer because we need to substitute back our u here. Okay, kena ganti balik u kita kat sini. Okay, because the final answer should be in term of x, not u. Okay, we let you just to simplify our integration. Okay, when we have multiplication of two function, then that function can be differentiable. Okay, can be differentiable means that we let u, then it can be differentiable. Okay, so when you substitute back, then the solution should be -1/4 cos. So your u is 2x squared and then plus c. So this is should be your solution. Okay, your final answer. Okay, let's say I have number 5. Look at number 5. Okay, student, look at number 5. Can you tell me what is your u? Okay, so what is your u for this number 5? What should be our u? Okay, integrate x over square root 1 plus x squared dx. So, what is the best selection of our u? Apa yang kita nak pilih sebagai u kat sini?
Square root 1 plus x over 2.
Square root 1 plus x square.
X square.
Oh, okay. You nak pilih semua. Semuanya sekali sebagai u. Okay? Boleh? Kalau you kata macam tu. So, u equal to square root 1 plus x square. Okay? So, I rewrite in term of this. 1 over 2. Okay? So, if you differentiate this du dx, okay? Remember, after you choose u, okay, equal to 1, and then you need to differentiate with respect to x. So, differentiate this, we get 1 over 2, 1 plus x square, power minus 1, okay, multiply with 2x. Okay, multiply with differentiate this term. Okay. So, if I simplify, so this I can cancel with this. So I should have x here. Okay. And then this term here. Okay, so I should have here x. Alright, sorry. X 1 plus x squared power negative half, or I can write this as du dx equal to x over, so power power negative half, so I bring out I bring to the denominator here. Okay, so I should have square root 1 plus x squared. Okay. Okay, so it seems like, can you get back the rest of the term? Can we represent? If I rewrite this, okay, so I should have du over, if I want in term of dx only. Okay, so I have x dx, and then, okay, because I can write this term here, x dx, so x dx is equal to square root 1 plus x squared du. Okay, this one. I bring here and then write here. So I have this. Okay, so if I write in terms of u, okay, so look here, integrate x over square root 1 plus x squared dx. So integrate, okay, so you let this as u. Previously, you told me that this as your u. And then x dx ialah this one. Square root 1 plus x squared du. Okay. Wait, I double check first. U square root 1 over x square. Okay, 1 plus x square power half. So half 1 plus x square negative half. Okay, so negative half you have 2x here. So you have x 1 power negative half here. So x over half. So you have back here 1 plus x square x dx. Okay. So this is actually your u. Alright. So you can just simplify this. So this is also your u. Okay. So it's just actually 1 du. Okay. So 1 du. So if you integrate this, you get u plus c. Okay. And then you must to substitute back your u. Substitute back your u in order to get the correct answer. 1 plus x squared plus c. Okay. Alright. So actually you can either substitute as u equal to this, or you can also, I think you can also choose u equal to 1 plus x squared. Okay, because if you differentiate this, you can also get du over dx equal to 2x. Okay, which give you 1 over 2 du equal to x dx. Okay, but you will have in terms of square root. Okay, so this is also correct, or you can use u equal to 1 plus x squared, also correct. Okay, so good. So clear about integration by using substitution. Okay, boleh boleh. Ada soalan? Any question? Okay, any question? Integration by substitution. Okay, not? Okay, so if you refer to slide, okay, I also have another example here. Okay, I give you several exercises here, so you may try later together with the answer. Okay. So now we move to second technique, integration by part. Okay, boleh kita move to integration by part. Okay, now we move to integration by parts. Alright, so look at this integration by parts. Okay, you read first. Okay, you read first. Okay, student, ada ke tak ni? Diam dah ni?
Ada.
Ada, madam.
Okay, can we move to integration by parts? Okay, boleh? Okay, by substitution tadi boleh faham Okay, so the selection of u. Alright, so now we move to integration by parts. Okay, for integration by parts, if you cannot use integration by substitution, okay, let's say you have multiplication of two functions, but we cannot choose any function to be your u. Okay, kita tak boleh pilih mana-mana pun sebagai u kita. Then we have another alternative. We can use integration by parts. Okay, so look at this slide here. Okay, integration by parts. So for integration by parts, this is how we find the solution or the integral. Okay, so you have two functions. Okay, you have two functions, multiplication of two functions. So you decide as u dv. Okay, u dv equal to uv minus integrate v du. Okay, uv minus integrate v du. Okay, so from here, from the function, from your problem, okay, let's say you have this, look at this example here. You have x squared sine phi x dx. Okay, you have x squared sine 5x dx. So the question is, what should be our u? What should be our du? How to decide u and du? Okay, let's say you have this x squared sine 5x dx. Then how to decide u and du? Okay, so u means that the selection of u, you will do the differentiation process. Okay, the selection of dv, later on we implement integration process. So we have a technique that we call as tabular method. Okay, pernah tengok tak teknik ni? Have you used this technique in your integration? Pernah guna?
Pernah.
Okay, tabular methods. Okay, tabular methods. Okay, so tabular method is actually the simplify. Okay, we simplify our integration by parts. Okay, but theoretically it's same lah. Okay, uv minus v du. So how to decide your u and v? We have these rules here or guideline here. Okay, so if you look at this table, yellow table here, yellow box here. So choose u to be the function that comes first in the list of logarithm or ln, polynomial, exponent, trigo. Means that when you look at your function, you must to identify, is it this is a logarithmic function, polynomial function, exponential function, or trigo function. Okay, in order to decide your u. Okay, so this is the order. Okay, precedent order. If your function, for example here, okay, your function involved of this one is x squared is a polynomial. Okay, so x squared is a polynomial function. Okay, x square tambah 3, x square power 4 tolak 4x. This is a polynomial function. And then this one is trigo. Okay, trigonometric function. So look here, which should be your u? Okay, which one we should decide as our u? If we have polynomial multiply with trigo.
X squared is the u.
Okay, so x squared should be your u because x squared come first. Okay, look at the order. Ln, so we don't have ln, okay, because this function involves polynomial trigo, so we don't have ln, but we have polynomial. So we need to choose u equal to x squared, okay, and then the rest itu sebagai dv kita. So dv equal to sine 5x dx. Okay, so this is should be your u. Okay, the selection of u, g prime x dx as your dv. Okay, so if this example, the trigo, polynomial become your u. Okay, LPET. Lukman, please mute first. Okay, thank you. All right. Okay, so when you fill in your tabular methods, okay, you put your u here at the column of differentiation here. So this is for u, okay, this is for dv. Okay, so for for function that we assign as u, we do the operation, we differentiate. Okay, for dv, we do the process of integration. Okay, so let's look at example. Okay, and then we put the symbol or the operation here or positive, negative, alternately, positive, negative, positive. Okay, because it's follow this rules here. Okay, minus integrate v du. Okay, let's look at example. Okay, so let's say you have this example 1. Okay, look at this. X squared exponent 3x. Can I use substitution? Can I use substitution if I have x squared multiply with exponent 3x? If I want to integrate by substitution. Okay, can or not? Can we use substitution or not to evaluate this integral?
No.
No.
Okay, no. Why? because we cannot let u, right? Okay, we don't have any selection for our u. If we use u equal to x squared, then we cannot have exponent, okay? The rest of the term. If I let exponent of my u, so how can I get my x squared, okay? So this problem, we cannot use substitution, okay? So that's why we need to use another alternative technique of integration, integration by parts, okay? So please decide what should be your u. You have x squared, exponent. What
X
should be your
square,
u? Okay.
polynomial.
Okay, good, Lukman. So x squared is polynomial. So based on the precedent here, LPET. So we have the polynomial here, x squared, and then we have another function, exponent, 3x. Okay, so because exponent is the first function, because we have the polynomial, and then based on this order, so this should be our u. Okay, so this should be our u, and then exponent 3x should be your dv. Okay, means that exponent 3x. Okay, so ini saya tak tulis lah, saya tulis u saja because u LPET to decide your u. Okay, so it means that this as your u, and then this is as your dv. Okay, so I write here, we use tabular methods. Okay, we use the idea of tabular method. All right, to use integration by part, actually we should have integrate u dv is equal to u v integrate minus integrate v du. Okay, so this is the standard form of integration by part. But now we try to simplify this by using tabular methods. Okay, tabular methods. So we already decide u equal to x squared. Okay. So for u, we put under differentiate. And then for v dv, we put under integrate. Okay, so we have here x squared, and then here we have exponent 3x. Okay, means that we need to integrate exponent 3x dx and so on lah. Okay, so first we differentiate first. Differentiate. Okay, focus on this column. This is your u. Alright. Differentiate x square, kita dapat 2x. Okay, differentiate x square, kita dapat 2x. Integrate exponent 3x. What do you get? Integrate exponent 3x. Dapat apa? Integrate exponent 3x. Okay, so student, please tell me integrate exponent 3x. What did you get?
Exponent 3x over 3.
Okay, good Irfan, good Nash. Okay, so exponent 3x over 3. Okay, so do we need to stop? Do we need to stop or we still need to differentiate?
Need to differentiate it.
Okay, kita kena differentiate lagi sebab kita tak dapat. Dia kena berhenti once you get 0. Okay, you start when you get 0 at the column of differentiation. Okay, so differentiate lagi 2x, you dapat
2.
2. Integrate lagi dapat
0.
Integrate dulu.
Exponent 3x over 9.
Okay, good. Integrate lagi. Exponent 3x over 9. Okay, lepas tu differentiate 2 dapat
0.
okay, 0. And then this part integrate.
Exponent 3x over 27.
Okay, very good. Exponent 3x over 27. Okay, but before we do the multiplication, this we put plus, minus, and then this kita akan multiply silang lah, cross macam tu. So this term multiply this, okay, this function multiply with this, okay, and then, okay, so this multiply with this. Because this is already 0, actually this term kita multiply like this. Tapi apa-apa multiply with 0, so it's already 0. Okay, so what should be our solution based on this tabular method? Okay, so integrate x square exponent 3x dx by using integration by part. Okay, instead of we use u v minus integrate v du, okay, so we use tabular methods. So hasil dia ialah positive x square multiply with exponent 3x over 3, so we have x square exponent 3x over 3, and then negative 2x multiply with positive this, so we have negative 2x exponent 3x over 9, and then we have positive here multiply with positive, so we should have plus 2 exponent 3x over 27, and then if we multiply this term with 0, so we get 0, and then don't forget to multiply with c, because this is definite integral. Okay, so if you want to factor out your exponent 3x pun boleh. Kalau tak nak, okay, to avoid mistake, so keep like this, okay? Keep as it is je lah, tak payah simplify lagi. Okay, good. Okay, so let's look at another example, okay? So this is the solution, okay? So I already paste or put here the solution. Okay, let's look at another example. Evaluate exponent 2x cos x by using integration by part. Can you tell me what is your u? Okay, what should we select as our u based on the LPET? What should be your u?
Exponent 2x.
Into x.
Okay, exponent, because you have ln, we don't have ln. Polynomial, we don't have polynomial. And then the next one, exponent. Okay, so we have exponent. Then the last one, trigo. So exponent come first, okay, because we have that function exponent. So choose u equal to exponent to x. Okay. So we have here LPET. So from this problem, ln tak ada polynomial, but we have exponent to x here, and then we have trigo is cos x. Okay, so the selection of our u should be exponent to x. Okay, all right, you are very smart. Good. Okay, so now we check with the tabular method first. We do the tabular method first. Okay, so this is your u. This everything here should be your v. Okay, integrate u dv. So uv minus integrate v du by using integration by part. But this time we use tabular method in order to simplify or facilitate us in integration by part. Okay, so we have the differentiation here, differentiate. And then we have integrate here. Okay, so here is exponent 2x. Here is cos x. Okay, student, can you tell me differentiate exponent 2x?
2 exponent 2x.
All right, good. 2 exponent 2x. And then at the column for integration, integrate cos x. What do you get?
Negative sign
Negative
x.
signs.
You only bertukar-tukar.
Sin x.
X.
Aduh lah. Kalau integrate cos, positive sign. Integrate sign, negative cos. Ni, simpan kat sini, simpan kat sini. Boleh? Ingat satu je. Integrate cos, positive sign. Okay, because differentiate sign, you dapat positive cos. Okay, so here should be sin x. Okay, what happened? What happened here is actually, okay, takut ada yang tak nampak, is the integrate cos x dx. Integrate cos x dx, so you dapat this one. Okay. Okay, so differentiate lagi. Differentiate 2 exponent 2x. What do you get?
4 exponent
4x
2x.
2x.
Okay, 4 exponent 2x. And then integrate sin x.
Negative cos.
Okay, this time negative. Negative cos x. Okay, negative cos x. Oh, it seems like tak habis. Okay, we never get 0. Okay, can we get 0? Either differentiate or
No.
integrate. Okay,
No.
we cannot get 0. So when should we stop? Bila kita nak berhenti? Huh? When should we stop? Exponent, cos, never get 0. Okay, so when should we stop our tabular method? Bila kita nak berhenti?
Bila kita dapat balik nilai tu,
Nilai mana? Nilai tu nilai mana? Nilai apa?
cos x tu.
Okay, so as Irfan share, as Irfan said, once you get back, okay, you start with cos x, you integrate, okay, you get back cos x. Okay, tak kisahlah negative or positive, because we deal with exponent and trigo. If you differentiate or integrate, both never 0. Okay, kita tak akan dapat kosong. So dia tak akan stop sebenarnya. Okay, so when should we stop our tabular methods? Is when you start with cos, then you do the integration, and then you get again, okay, you have again cos x. Then you stop your tabular. Okay, we stop here, and then we put plus, minus, plus. All right, this term we multiply with this term. This term you multiply with this, and then this term you multiply back here. Okay, this term you multiply back here. Alright, so apa kita dapat? Okay, so let me write here. Hasil dia, integrate exponent to x cos x dx. Okay, so we have here positive exponent to x multiply with positive sin x. Okay, so I should have here positive exponent to x sin x. All right, and then the next one, negative 2 exponent to x multiply with negative cos x. So negative multiply with negative, you should get positive. Okay, so you should have plus here 2 exponent to x cos x. Okay, untuk di sini, okay, when you integrate, when you multiply back cos and also the term in your differentiation, at this part you must to put the integration. Okay, you must to put the integration. So you have negative multiply with positive, so you may have negative, so you should have, you must to put in integrate back. Okay, because it's a never stop process. So what we have here is 4 exponent to x cos x. Okay, so how about this exponent? So you look here, on your left hand side you also have integrate exponent to x cos x. On your right hand side you also have exponent to x cos x. Or I can write this, okay, or I can write this actually, I can bring my 4 outside. Okay, if I put my 4 outside here, so it means that we collect the same term here. Okay, to simplify this, you bring this to your left. Okay, means that you have integrate exponent to add cos x dx. Okay, here also dx plus 4 integrate exponent to x cos x dx. Okay, so equal with what you have on your right hand side. Okay, this is our right hand side. Exponent to x sine x plus 2 exponent to x cos x. Okay. Okay, student. So you look here. Okay, so you look here. You have the same term. Okay, let's say if I represent this as my A, this is also my A. So I have A plus 4A, so I should get 5A. Okay, so now I have integrate exponent to at cos x dx plus 4 integrate exponent to at cos x dx. So if I simplify this, my left hand side, I should have 5 integrate exponent to x cos x dx equate with my right hand side exponent to x sine x plus 2 exponent to x cos x. Okay, but we want only this. Okay, kita nak integration saja because this is our main problem. Okay, this is our main problem. So we can divide 5 on left and right hand side. So if I divide 5 on my left hand side and I divide also 5 on my right hand side, so my final answer should be integrate exponent to x cos x dx is equal to 1 over 5 exponent to x sine x plus 2 exponent to x cos x, and then don't forget plus c. Okay, because this is indefinite integral. Okay, without limit. Alright. So contoh saya semuanya tak ada limit, tak apalah. Okay, yang penting you get that idea on how to apply the integration technique. Okay, any question? Ada soalan integration by part? Any question? Integration by part. Okay, so this is the solution. All right, step by step solution. So I believe that you clear on how to select your U. Okay, based on LPET. Okay, so you may try this exercise. Okay, we have several exercises here, so you may try this. Okay, because we are running out of time, so let me move to the last technique. Okay, partial fractions. Okay, boleh semua pelajar faham? Ada lagi ke tak ni? Ke dah tidur dah? Okay, so far. Okay ke tak? Faham ke tak?
So far okay.
Okay, good. Alright. So, ada 54 pelajar ni, tapi yang lain ni mungkin dia apa? Kusyuk. Kusyuk. Dia kusyuk. Mendengar penerangan. Okay, it's good. Okay, so hopefully you faham lah walaupun you tak apa respond. Alright. Okay, so let's look at the last technique. Okay, integration by partial fraction using partial fraction. Okay, so when should we use this technique? Okay, so tadi kita dah tengok by part, kita dah tengok substitution. Okay, we have already looked at substitution by part. Okay, substitution, if you can let U and then you differentiate, you can present the rest of the term in term of U also. Okay, if you cannot do so, so you must to move to by part. Okay, integration by part. So in integration by part, you have multiplication of two functions. Then you need to decide what is your u, what is your dv. Then you can use tabular method. Okay, how about partial fraction? Okay, partial fraction, you implement this technique when you need to integrate function, okay, in this form. Okay, you have fx dy with gx. Okay, this kind of function we call as rational function. Okay, you have a rational function. Okay, rational function. So basically the idea is based on proper integral, pecahan wajar. Okay, proper integral. Proper integral means that the power of your numerator less than power of denominator. Kuasa yang function dekat atas tu lebih kecil daripada kuasa yang dekat bawah. Okay. Alright. So this time we use partial fraction. Okay, look here. Suppose we need to make the integral of polynomial rational. Okay, you have function x over your another function x. Okay, let's say fx over gx or mx over nx, which m and n are both polynomial. Okay, for example, you have x plus 1 over x cubed plus 3, for example. Okay, then you need to use partial fraction. And the integral cannot be evaluated by simple methods, so we need to consider below step. Step 1, the degree of numerator must be less than the degree of denominator. So this is what I said. Okay, it's degree kuasa bagi yang belah atas mesti kecil daripada kuasa yang pembawah. Okay. Denominator must be written as the product of prime factor. So maksudnya you can factorize the denominator. Okay, this determines the form of partial fraction. Okay, so there is a several form of partial fraction, general form. So how to write the general form of partial fraction? You must look at your rational function. Okay, for example, you have linear factor. Okay, linear factor. What is mean by linear factor? Linear factor means you have function of degree 1 multiply with another function of degree 1. Okay, linear factor. So you look here, for example, you have x plus a power 1 multiply with x plus b power 1. So this we call as linear factor. Okay, because the highest power is 1. Okay. So how to write your form of partial fraction? So you must to write in this form. A over x plus a plus b over x plus b. Okay. In other words, when you decide your partial fraction, okay, when you decide your partial fraction, this one, okay, when you decide your partial fraction, if you simplify these two fractions, you must to get back your original fraction. Okay, dia mesti kena equivalent. Bila you present in partial fraction, you write in general form, you multiply this fraction, okay, you expand and you simplify your right hand side, you must to get back what you have on your left hand side, especially at the denominator. Okay, for example here, if I want to solve this two fraction, so I must to have a over x plus a, and then I need to times here, I might to multiply with x plus b, and then above here also I must to multiply with x plus b, and then plus I have here b over x plus b. Okay, so remember how you solve fraction, you must to equate the denominator. Macam mana kita selesaikan fraction? Kita kena samakan penyebut. Okay, samakan pembawah dia. Pembawah dia mesti kena sama. Okay, equivalent. So, yang ni kita darab dengan x plus a, and then above here also you multiply with x plus a. So that you may get a x plus b plus bx plus a, and then denominator is x plus a multiply with x plus b. Okay. So dia akan tally dekat sini. Okay. This right hand side, denominator for your right hand side must be equal with the left here. Okay, what you have on your left here. Alright. So this is the rules. Okay. Okay, this is the few rules here. If you have linear factors, so this is your general form of your partial fraction. If you have repeated linear factor, let's say you have 1 over x plus 2 cubed. Okay, let's say you have 1 over x. If I use function, fx is in term of function. Let's say you have x over x plus 2 cubed. Okay, so how to write in term of partial fraction? So general form should be like this. A over x plus a means that a over x plus 2 plus b over x plus 2 square. Okay, dia increase kat situ. And then plus c over x plus 2 cube. Okay, sehingga kuasa kat sini lah. Kalau kuasa 4, you ada lagi term plus d over x plus a power 4. Okay, ini kalau you ada repeated linear factor. And then this is for quadratic. Okay, so this form, saya rasa you pernah tengok lah. Okay, you have that idea. But the problem normally student write wrong partial fraction. Okay, you write a wrong form of your partial fraction. So the keyword is, in order to use partial fraction, look at your denominator. You kena tengok kat denominator apa yang awak ada. Okay, for example, here you have linear multiply with linear. So this is should be your partial fraction form. Okay, you have linear factor multiply with linear factor. Means that you must have two fractions. One belong to first linear factor, and then you must plus with another fraction over the second linear factor. Okay. If here you have three linear factor, x tolak 2, x minus 2, x plus 3, x plus 5. So you must have three term of your partial fraction. Pecahan separa. So when we want to represent, we must have fraction, fraction, fraction. Okay, partial fraction. Okay, so you must have three fraction here. Belong to each of these linear factor here. All right. Okay, so this is general form if you have repeated linear factor. Okay, so you boleh tengok example dekat sini. So slide ni saya bagi. And another one you have irreducible quadratic factor. Okay, this means that your quadratic function cannot be factorized into two linear factor. Kalau awak ada function quadratic tapi tak boleh nak faktor dalam dua linear factor, so kita akan guna ini. Okay, maksudnya that denominator you keep as quadratic function. So it means that your partial fraction should be like this. The term for your numerator. Okay, numerator term dia mesti the power must be 1 less than the denominator. So denominator highest power 2. So when you want to write your numerator, it must be linear, cx plus d. Okay. Alright, so let's look at example. Okay, sikit lagi masa. Okay, the last one lah. Okay, the last one, integration by partial fraction. Let's look at this example. So can you help me? Tell me what is your partial fraction form? Boleh bagi tahu saya apakah bentuk partial fraction kita, please?
Linear.
Apa?
Linear form. Linear form.
You have linear factor, so how about your partial fraction form? Can you tell me your partial fraction form? Apa bentuk partial fraction kita? Apa kita perlu tulis? What should we write to represent our partial fraction?
A over x plus 2.
Okay.
plus b over x minus 1.
Okay, good. Okay, good. Thank you. Very good. So since you have x plus 2 minus x minus 1, okay, you have multiplication of two linear factor. This is linear. This is also linear factor. Okay, so in order to simplify our fraction in terms of partial fraction, so we must to write this in a over x plus 2 plus b over x minus 1. Okay, all right. And then how to solve two fraction? As I told you, to solve fraction, you must to equate the denominator. Okay, so tengok dekat sini. This term, we missing x minus 1. So we multiply with x minus 1. Okay, so above also you must to multiply with x minus 1. Okay, so for this term, we missing x plus 2, so we must to multiply with x plus 2, and above also you must to multiply with x plus 2. Okay, so simplify this. So I have a multiplied with x minus 1. So below here is x plus 2, x minus 1, and then plus b multiplied with x plus 2 over x minus 1 multiplied with x plus 2. As I told you, for multiplication, no need to worry the position. A times b equal to b times a, means that x plus 2 times with x minus 2 equal to x minus 2 times with x plus 2. So it means that these two terms here, okay, this linear factor here is equivalent with what we have on left hand side. Okay, dia mesti setara. So x plus 5 over x plus 2 x minus 1. So here we have a x minus 1 plus b x plus 2, and then our denominator is x plus 2 times with x minus 1. Okay, so when this denominator here is equivalent, okay, so persamaan tu balance, seimbang, so we focus on solving our numerator part. Okay, so we focus on solving our numerator part because we want to calculate what is our a and what is our b. Okay, so from here I should have x plus 5 equal to a x minus 1 plus b x plus 2. Okay, for linear factor, okay, special for linear factor, in order to solve, we let the value of x so that the term or the substitution becomes 0. Okay, so in this case, we let x equal to 1. Okay, if I let x equal to 1, so I can make this become 0. Okay, so what I have here, 1 plus 5 equal to a, so here 1 minus 1, so 0 plus 1 plus 2 here. Okay, so I should have here 6, and then a times 0, 0, b times 3, so 3b here. So here I should get b equal to 2. Okay, and then another one I let, okay, another one I let x equal to negative 2. So that if I let x equal negative 2, I can make this term 0. So I can eliminate b. I only have a. Okay, so what should I have here is, okay, negative 2 plus 5 equal to a times with negative 2 minus 1, and then plus b times with negative 2 plus 2. Okay, students, so this term 0. Okay, we already eliminate b. We left with a. All right, so negative 2 plus 5 is positive 3. -2 minus 1, -3a. So what we have here, a equal to -1. Okay. All right. So what you have here, you substitute back into here, the first part yang kita let tadi. Alright, kita nak ganti kat sini. So it means that, okay, now by using partial fraction, integrate, okay, my original function x plus 5 over x plus 2 times with x minus 1 dx. I can write in terms of my partial fraction here, okay, by substitute my a and b. Okay, so what I have here, a is -1 over x plus 2. Oh, sorry, x plus 2 dx, and then plus my b is 2 over x minus 1 dx. Okay, so what do you get, student? If you integrate -1 over x plus 2, dapat apa? Integrate the first term, dapat apa? What do you get? Integrate -1 over x plus 2. Okay, this you should get ln. Okay, you should get ln because the highest power of your denominator is 1. Okay, kita tak boleh bawa dia naik atas. So this you should get negative ln absolute sign x plus 2 and then plus 2 ln x minus 1, and then don't forget plus c. Okay, because this is indefinite integral. Okay, so this is our solution. I ada bagi juga dalam slide tu. Okay, so this should be your solution. Okay, ada soalan? Any question? Any question? Okay, so I leave it to you, the rest. Okay. Okay, so the rest because kita pun dah pukul 12 lebih. Okay, saya tahu saya tak nak guna masa yang panjang because you also need to allocate some internet data. Okay, so I believe that you have something today. Okay, can you give me response? Is it today's session? Differentiation and also integration membantu atau tak? Okay, dapat tak ilmu itu? Memberi manfaat atau tak? Have you get something?
Yes, madam. Dapat.
Membantu.
Yes,
Bantu
madam.
juga.
Ya, dapat bantu.
Kalau tak sebelum ni, tak tahu apa-apa.
Thank you, madam.
Okay. Alright. You can get the material from the email. Kita dah email. So, saya ucapkan, saya, Dr. Rosie dan all your mathematics lecturer, we wish you good luck for your next week. You have tests, okay, for applied calculus, for ordinary differential equation or the other subject, okay, statistik tu kalau you ambil. So we wish you all the very best, okay, for your upcoming test.